Okay, so if we have a random variable x and it has a normal distribution, so to signify that it has a normal distribution, we write this little squiggly tilde and then we do capital N, we write mu sigma squared, where sigma by itself is the standard deviation, so sigma squared is the variance and mu is the mean. So we're all familiar with what the mean is. The standard deviation is essentially the average variation we have from the mean. So the average distance that our points are from that middle point. The graph, so this is an x-axis here, mu here, so we peak here, we come down equally on either side, not the best route in the world. Anyway, so this is our point mu here, and one nice feature of the graph is the symmetry. We're going to be working with some hypothesis testing and other things with normal distributions in the future. It's quite a common distribution. I'll just mention a few features now. So obviously we start very concentrated in the middle, then we get these tails coming out. It so happens that about 99% of the data is within 3 standard deviations of the mean. Okay, so this distance here is sigma, then we go that distance again and again, well, and then we do that on the other side too. 99% of the data is within this chunk here. Okay, and for those interested, the probability density function, of course, this is continuous, so you can take any value along this point. So the probability little x, okay, so well x, but little x is a particular value equal to 0. That's true for all continuous distributions, but we can still write a density function like this is still relatively more likely to appear than some of the values, even though the probability that particular values appear is 0. So the PDF is given by f of x is equal to 1 over sigma square root 2 pi e, so let me just rub this out, e to the minus a half x minus mu over sigma all squared. Okay, so that's just if you're interested. And then what we're going to move on to now is the sum of normal distributions. What we require for this is we want x1, x2, xn independent, not necessarily identical, but all normal distributions, mu I, mean, and sigma I squared. So this subscript I corresponds to these numbers here, and that means that these are independent. Okay, so whatever x1 does doesn't affect x2, but the means and standard deviations can be different. It turns out if we sum up all these distributions, so we take the sum from I equals 1 up to n of xi, which is clearly x1 plus x2 all the way up to xm, this also takes a normal distribution. And the mean, conveniently, is just the sum of the means of the individual distributions. And the sum of the variances. The variance is just the sum of the variances. Okay? Yeah, so that's important. Sigma is equal to the standard deviation, and the sigma squared is equal to the variance. Alright, we're going to look more at normal distributions in the upcoming videos about transforming normal distributions, checking whether data is modeled by a normal distribution, and the like. But hopefully you enjoyed this introduction to normal distributions. If you did enjoy the video, please be sure to like and subscribe. If you've got any questions, then let me know down in the comments. I'll try my best to clarify anything for you. Now that's it, and I hope to see you in the next one.